Today we are going to talk about our project question answering system. The outline of this video has three steps. First, go through the slides for overviewing of the project. Step 2, displaying the code, and Step 3, a small demo of our question answering system. First one, introduction. What is question answering? Question answering is a computer science research field for information retrieval and natural language processing. Question answering system is aimed on building systems that automatically answer questions posed by humans in a natural language. There are two types of question answering system. First, closed domain, only answer limited types of questions. Second, open domain, deals with questions about nearly anything, rely on the word knowledge. There are nearly 5 types of different questions that question answering system need to answer. First, factoid questions. Generally start with WH word like what, when, where, which. Second, list type questions is a series of factoid questions. Hypothetical type questions always begin with what would happen if. This type of question asks for information related to any hypothetical event. Confirmation questions. The answer of the confirmation questions is yes or no. Causal questions is a difficult questions to answer and always like why questions. The question answering system architecture has 3 modules. First, question processing. This module analyzes questions and classification questions and reformulation questions. Second, document processing module. In this module, the system will search for the answers with their domain and find the context and the paragraph for the answer. Third, answer processing module. In this module, we will identify answers, extraction answers, and validation answers. And then overview of our project. In our project, we designed a closed domain question answering system, which is based on a dataset containing both questions and answers. The dataset is a Facebook research dataset called BABI dataset. And for the natural language processing part, the word representation method is GLOVE. And for the machine learning method, we use the dynamic memory network DMN to training and testing our system. In order to have the more convenient interact with users, we create a web interface to type in the context and the questions and the response with answer. The BABI dataset is a Facebook research dataset. The goal of this dataset is automatic text understanding and reasoning. The dataset contains straightforward questions, and all the questions in this dataset have associated context and the correct answer. There are 20 different tasks based on what skills are required to answer the questions. And here is a dataset format and example. For the contest, there is different IDs for that test, and IDs for the questions, answer, and the supporting fact IDs. The IDs for each question and the stories IDs continues like 1, 2, 3, 4, and every time start a new story, it go back to 1 and start another count to 1, 2, 3, 4, and here is an example of the data, including contest, questions, and answers. For the word vectorization, we use GLOVE. As you can see, one sentence is parsed in several tokens. Each word is one token, and each token gets individually vectored and stored in the matrix. There are some unknown tokens we have to deal with. A new vectorization from the original GLOVE vectorizations, and then we have this new vectorization and add that vector back to the GLOVE word map. And here is the coding for the vectorization of this one. Here is turn the input paragraph into the matrix and handle with unknown and known vectors, and then contextualize the matrix, and which contains 7 elements to do this. And then the data processing part. The user inputs text and questions based on the BABI dataset format, and the system will vectorization the word and solve the unknown tokens. The format of the context, the format of the data will be a question and answer context tuples, and for each beginning, there is a Markov-Newton synthesis and split the data into training and testing format. And here is the code. Here is the data processing part. First, we unzip the tasks and the gloves. We use the BABI task 5 to. We use the BABI task 5 to do the question answering system, and then we unzip the glove and to vectorize the data.
So in the next part of the video, I will show the method in our project and show the demo of the project. The method we use in this question-answer system is a dynamic memory network, which we refer from a paper that we mentioned in the report. And the model contains 4 parts of element. As you can see, the first model is input model, and it's based on a gated recurrent unit. And the second model is question model, which is the easiest model in the project, and which this only contain one pass of the text of the question. And the third model is episodic memory module, which is the most complex module in the network because it uses attention to do multiple passes, and each pass consisting of GRUs iterating over the input. And attention is an mechanism used in image analysis. And the fourth model called answer model, which is the final model to regresses from the question and episodic memory modules output using a fully connected layer to a final result word vector. As you can see in our code, after we set some hyperparameter of the network, we start to build up the structure of the network. And the first module here is the input module. The second question module only contains one pass of GRU unit, and the third episodic memory module is the most complex one. Then comes with the last module, which is the answer module. And after we build up the model of the network, we start to train the network, use our training dataset. And our optimizer is Adam optimizer. And here is the result of the training procedure. We trained the network on a GPU for almost 20 minutes, and which after 4,000 of iterations, it get the almost 90% of accuracy of training procedure. And this is a picture. We can say the accuracy achieved 90%. And this slide shows the testing performance. We tested the trained model on some testing data. Our testing data is collected from the user input. Like we can say in this figure, the user inputs the context and the user inputs the question. Then the network will respond the text to the question, and they will evaluate and return the response. They also respond the expected answer, which we can compare with the response that the network generated. In these two examples, these two answers are all corrected, so the testing accuracy is 1, which means 100% accurate. And to make user have a good interaction with the QE system, we design a web interface. So the framework we use is called WebPy, which is a web framework for combine the Python with the web development. So in the upper figure, the user can input. The user need to open a local web page, which in this address, and they can input a context and a question in the system required format. and when they click the submit button, the network will use the information they inputted and then return the answer. And in this figure, we can say the response is the same as the expected answer, which means the network gives the user the correct answer. So in our code, the last part is the web design part. We need to import a web module first, and we design a form which display on the web page in the browser. Then we first get the content from the form that user input. Then this input information will be formatted in our testing dataset, and the network will evaluate on this testing dataset and give the answer to user, and then the output of the network will return and displayed on the web page. So this is all stuff of our project.